Hey everybody, this is lesson 82, writing the recursive rule for a geometric sequence. Remember that you can pause the video to take notes or to work ahead on a practice problem and then hit play and I'll come back and we can see if we agree with the answers that you got. All right, so we're writing recursive rules. We just did recursive rules for arithmetic sequences. Now we're just going to extend that to geometric. So we're writing recursive equations or formulas for geometric sequences. So the recursive rule, just like for our arithmetic one, has two equations. The first one is going to be about the first term, and then the second one includes the common ratio. So the difference here between what we were working with the arithmetic one is that we now have this r, the common ratio involved. So a sub 1 equals a number. That's going to be the same as our arithmetic. A sub n equals, and we've got a sub n minus 1. That's going to be the same thing, except now we've got to make sure that we have this multiplication and r, our common ratio, is involved. So we're going to find the first 5 terms of the sequence in which a sub 1 is 5 and a sub n equals 3 times a sub n minus 1. Again, remember that the hardest part of this is understanding the notation, understanding what this a sub n minus 1 means. So we're going to work a little bit more on that in this problem. So a sub 1 is 5. And why is that 5? Well, it's because they told us that the first number was 5. So because those are both 5s, we know what a sub 1 is. A sub 2, we're going to plug a 2 in for n here and n for this n over here. So we're going to end up with 3 times a sub 2 minus 1. And then we're going to simplify that 2 minus 1 down. So that's really going to be 3 times a sub 1. And a sub 1 is that 5 that we got in the last answer. So we're going to just pull down that 5, and 3 times 5 is 15. So the second term is 15. And yes, that 5 is the same as the very first 5 that we had. So our second term is 15, our first term is 5. All right, let's figure out our third term. So we have a 3 down here. So that's like putting a 3 in for n here. We're going to put a 3 in for this n over here. So we're going to have a sub 3 equals 3 times a sub 3 minus 1. You're having a hard time there probably seeing the minus. It shouldn't be minus. Why are these? Oh, no, that's right. Minus 3 minus 1, duh, is 2. So that's going to turn this into 3 times a sub 2. I was thinking, oh, we should be multiplying. But no, it's n minus 1. I don't know what happened there. All right, so 3 times a sub 2. Well, a sub 2 was that last number we found. A sub 2 equals 15. So 3 times 15 is 45. And yes, those 15s are the same 15s. You can use the number before, multiply by 3 to get the next number. All right, a sub 4 equals 3 times a sub 4 minus 1. So we're plugging in a 4 for our n's. And then we're going to simplify that 4 minus 1. That's 3 times a sub 3, sorry. And a sub 3 was that last number that we found. A sub 3 is 45. So we're going to have 3 times 45, and that's 135. And yes, those 45s are the same 45s. A sub 5 is going to be equal to 3 times a sub 5 minus 1. And so that 5 minus 1 is going to reduce down to a 4. So we've got 3 times a sub 4. And a sub 4 is that last number that we just found. So we really want to take 3 and multiply it by 135, and we get 405. So our sequence is, and yes, those are the same 135s. Our sequence is 5, 15, 45, 135, and 405. And we built that sequence by taking the first number and multiplying it and every number after it by 3 to get the next number. So that's the first 5 terms in our sequence. All right, so let's see if we can find the first 5 terms in this sequence, which starts with a sub 1 is negative 2. So we already know a sub 1 is negative 2. And to get the next number, we're going to plug in the number before. That's the a sub n minus 1. And we're going to multiply it times 4. So to get a sub 2, we're going to do 4 times the number before, which is -2. 4 times -2 is -8. To get the third term, we're going to do 4 times the number before. Well, the number before we just found was -8, sorry. And so 4 times -8 is -32. To get the next number, we're going to do 4 times the number we just found. So 4 times -32, and we'll have -128. And then to get the fifth number, we'll do 4 times -128, and we'll get -512. So our sequence is -2, -8, -32, -128, -512. All right, the next one, the first 5 terms in the sequence, we already know the first one's 16 because they gave it to us. And then we're going to take that 16 and we're going to multiply it times 1/4 to build the next number. And then we'll multiply that times 1/4 and keep multiplying by 1/4. Okay? Technically, multiplying by 1/4, you're dividing by 4. So, same idea. So we're going to do 16 times 1/4. 1/4 of 16 is 4. To get the next number, we're going to do 1/4 times 4. 1/4 times 4 is 1. To get the next number in the sequence, we'll do 1/4 times our answer. So 1/4 times 1 is 1/4. And to get the last number, or the fifth number in the sequence, we're going to do 1/4 times 1/4, and that's 1/16. So our sequence is 16, 4, 1, 1/4, 1/16. All right, let's do another one. The first 5 terms in the sequence, which a sub 1 equals -1/2, and a sub n equals 2 times a sub n minus 1. So these two problems are probably a good time to go ahead and pause it and see if you can figure out what the 5 terms are for 4 and 5. And then unpause the video when you're ready, and then you can check and see if you're right. All right, so a sub 1 on number 4 is going to be -1/2. And then we're going to just multiply each answer that we get from the problem above, or the number before, we're going to multiply by 2. So to get the second one, we're going to do 2 times -1/2, and we're going to get -1. And then the next one, we're going to do 2 times -1 and get -2. The next one, we'll do 2 times -2 and get -4. And then we'll do 2 times -4 and get -8. So our sequence is -1/2, -1, -2, -4, -8. All right, example 5, our first term is going to be -27, and we're going to multiply each of those answers by 1/3 and then create our sequence that way. So 1/3 of -27 is -9, and 1/3 of -9 is -3, and 1/3 of -3 is -1, and 1/3 of -1 is -1/3. So our sequence is -27, -9, -3, -1, -1/3. Hopefully you did well. All right, let's use these tables to create a recursive rule that models the sequence. So a lot of times if they just give you a random table, you may have to first figure out if it is arithmetic or geometric. Since we're just talking about geometric right now, we can go ahead and assume that they're geometric, but that may be one thing that you have to figure out is it arithmetic, is it geometric before you start writing rules, because that's going to dictate what your formula is that you need to look at. All right, so we know that we need 2 terms, the first term, and we need to know the common ratio times a sub n minus 1. So we're filling in 2 pieces. So you can have this formula out when you go to write your rules, when you're working on a quiz or a test or something like that, and you're just really plugging in what a sub 1 is and what that common ratio is, and then you're done. So the first term is whatever's in the first position. So it looks like a sub 1 equals 0.16. And then we have to figure out what we're multiplying by. Our numbers are definitely getting larger, and it might be hard to tell down here, but remember, to find your common ratio, you take a second number and divide it by a first number. So a number on the right divided by the number just to its left. So 20 divided by 4 is 5. So our common ratio is 5. So in that spot where there's an R, we'll put in a 5. So a sub 1 equals 0.16. A sub n equals 5 times a sub n minus 1. And that's it. That's your equation. Recursive rule. I guess I should say equations, right? Because there's 2 of them. All right. So for the second table, a sub 1 equals, what number do you think? I'm thinking 1,000. A sub 1 equals 1,000. And let's try to figure out what we're multiplying by. Our numbers are getting bigger, so it's definitely going to be a number bigger than 1. Let's do 2,500 divided by 1,000. So that would mean that our R value is 2.5, or 5 halves. So A sub n equals 2.5 times A sub n minus 1. Both of those together are a recursive rule. Remember, you need to know how the sequence is changing, but also where to start. So you need both pieces of those. All right, so explain in your own words, what is the difference between explicit and recursive rules? What do you think? Here's what I think. I think explicit rules are made up of only one equation. You can plug in the position number and find the number in the sequence. Pretty easy. That's the strength of an explicit rule. Recursive rules are made up of two equations. In order to find a particular number in the sequence, you must find all the numbers in the sequence. So depends on how far out you're going. If you're going not very far, recursive is probably the way to go, right? You have the first 3 terms. You need to find, the 7th term. You don't have to go too far. Why write an equation? Just continue the pattern. But an explicit rule is for when you have to go way on down the road. We don't want the 7th term. We want the 700th term. So that's where an explicit rule is strongest, is if you have to go way on far down the line. So they have their pros and cons, and and that's why you're kind of working with both of them. But you are really kind of worried about making sure you understand that notation, really what you're worried about. All right, so let's write a recursive rule to model the sequence and then find the 6th term. So looks like our first number is 16, so A sub 1 equals 16. This one might need to figure out, it's kind of hard to tell what you're multiplying by. You're definitely multiplying by a number bigger than 1. So we may take 56 and divide it by 16. 56 divided by 16 is 3.5, or I wrote it as 7 halves here. Doesn't matter which one. All right, and we want to find the 6th term. So I already have the first 4 terms. So I've just got to find the 5th term and then find the 6th term, and then I'll be done. So I'm going to figure out what the 5th term is by taking that 686 and multiplying it by 7 halves, or 3.5. And when I do that, I get 2,401. To get the 6th term, which is the one that I really want, I'm going to take that 2,401 and multiply it times 7 halves, and I'm going to get 8,403.5. And that is my answer there. All right, so here we're going to find the 11th term, so we're going to have to do a little bit more work. I think I talked about it in the last video. It's going to be a little bit more tedious, but it's not too terrible. It's just pretty much you typing the same thing in the calculator over and over again, right? So we're going to write a recursive rule to model the sequence. So we know A sub 1 is 32.4. And we know, well, it's kind of hard to tell what our common ratio is. So I'm going to stick in my calculator 18 and divide it by 32.4. And when I do that, I get 5/9. It's like 0.5 repeating. If you want to call it 0.56, you can. Definitely give a couple decimal places. The more places that you give, the more accurate your answer, right? You don't have a rounding error as much. We have the first 3 terms. So to get the 4th term, we're going to multiply that 10 times 5/9. Now I think I switch over to decimals here. So I'm going to try to give 2 decimal places if I have room. Well, that one I didn't have room. So 10 times 5/9 is 5.6. And I'm going to multiply that by 5/9. I guess I'm going to just stick with 1 decimal place and get 3.1. Multiply that by 5/9 and get 1.7. Multiply that by 5/9 and get 0.95. Multiply that by 5/9 and get 0.53. Multiply that by 5/9 and get 0.29. Multiply that by 5/9 and get 0.16. And here's my last one. Multiply that by 5/9 and get 0.09. So that's the number that I'm looking for. Again, I probably would want to do a lot of this in the calculator and save the rounding for the end, but I didn't have enough room for that. So this is what I did. So it's probably got a little bit error. It's off a little bit. Probably could write it a little bit nicer as a fraction, but this is perfectly fine. All right, so if you are having to find a specific position, like what number's in that position, you're going to have to build the sequence. And that's what we did here. I had to go all the way up to 6, or I had to go all the way up to the 11th term, and I had to find all the numbers in between. All right, so that's it. That's the end of this video. I guess I'll see you in the next video. We'll be moving on to something a little bit different.